Okay, we're going to take the function f of x equals x squared minus x minus 12 over 2x squared minus 4x minus 16. All right, so we can break that down into what up here? X
minus 4 plus x plus 5.
Plus 3, is that what you said?
Yeah.
Okay. Over. Now, we have a 2, a 4, and a 16. What can we take out of that? 2. So we would have to take that 2 out first. I'm going to take it out over here. That leaves us with x squared minus 2x minus 8. Now, what can we factor that into? You notice I'm bringing my 2 over. That's going to leave us with what?
4.
And that's going to be, what are the signs? -4, positive. All right, very good. Okay. No, no, you don't have to. You need to stay above it. I gave you enough room on your paper to stay above that. All right, now, first thing we're going to do is we're going to look at the fact that we can do some simplifying. What can we do? X minus 4s can cross out, so let's do that. When we cross out the x minus 4s, what you have done in this case is you have found where the holes in your graph are going to be. Okay, so I want you to come over here to where your where we have the title of holes, and the hole for x is going to be at, where would this go to 0? 4. Positive 4, yes. All right. Now, that's just the x coordinate. We're going to have to figure out where the y coordinate is. Okay? So where the y coordinate is, we're going to take our x equal to 4. We're going to sub it back in to the x plus 3 over x plus 2 because that's what we have left. Okay? So we're going to sub that in. So we're going to sub it in right here. So we're going to sub it in for those x's. Now, we do still have the 2 down here, so we have to consider that as well. All right, so we would have, instead of x plus 3, we would have 4 plus 3 over the 2 times the 4 plus 2?
Yes.
So 4 plus 3, 7 over. 4 plus 2 is, and 6 times 2 is, so we would have 7. Okay. So that gives you a hole in your graph at 4 and 7/12. And there's your hole. You can't see it. Let me go a little darker. So 4 and 7/12. So that's the hole. Okay? So when you go to graph it, at that specific point, you'll have a hole in the graph. Yes, so this 4 over 7/12 is the actual coordinate where that point is going to be on the okay? All right, now next thing we're going to do is we're going to find the zeros. So we're going to find the zeros right here. All right. So my y-intercept is always where x equals 0. Okay. So if we look at our remaining x plus 3 over x plus 2, and we sub in, so we're going to sub back in here. So 0 plus 3.
What is x equal to right there?
0. Sorry. And 0 plus 2 down here as well. Don't forget times the 2 on the outside. That's going to give you what?
3 over 4.
3 over 4. Okay? So that's your 1 0. So that's 0 over. No, sorry. What did y'all tell me? 3/4, didn't you tell me? Okay. So that is X equals 0 on the y-axis, right? So that's your y-intercept. Okay? So that's your y-intercept. Now we're going to find our x-intercept. Okay? Your x-intercept is when your y equals 0, right? Your x-intercept will occur when your y equals 0. So if we come back to our original function up here, if 0 is in the numerator, and I have a number in the denominator, that will make this entire function go to 0, right? Okay? So all we need to do is set your numerator to 0. So our numerator in this case is x plus 3. So we set that equal to 0. So x would be a negative 3. So now we would have, for our x-intercept, we would have negative 3, 0.
Wait, so what's negative 3, 0? That's the
That is the x-intercept.
Do we just do that one? How come we don't do the y equal?
The y-intercept is this one. Hold on. This is the y-intercept. And this one is the x-intercept.
Okay, so Ms. Spencer, how come you didn't do
The bottom, because if I have a number and the numerator is 0, if I try to divide a number into 0, I'm automatically going to get what? 0. So we just concern ourselves with the numerator on that one.
Okay.
Yeah, Anthony?
What is y equal?
We're at, right. Y equals 0, or the smart, y equals 0. In other words, this function is going to be equal to 0 if the numerator equals 0. Because let's say the denominator was a 4. What's 0 divided by 4? 0. So we just take the numerator, which is the x plus 3, and we set it equal to 0. And that would satisfy, and that would find it. Okay? Any other questions? All right, now let's go down to our vertical asymptotes. That's nothing new. You can tell me about that one, can't you? Vertical asymptotes happen when? Vertical asymptotes happen when? So if I'm looking at an x plus 3 over 2 times x plus 2, where is this thing going to be 0? At negative 2, so, right? So if we have, let me just rewrite. So we have, what we have left is x plus 3 over 2 times x plus 2, right? When is this going to be undefined? At negative 2, right? Yeah, this is what you've been doing, right? So you just take your denominator of x plus 2. When is that equal to 0? That is equal to 0 at negative 2. So there is your vertical asymptote. All right? Now, your horizontal asymptote. All right, if you have a function, so in this case, we had two functions up here. We had the x squared minus x minus 12 over the 2x squared minus 4x minus 16. So technically we could think of those as two separate, basically quadratics, right? So I'm just going to rename them as a p of x over q of x. Okay? Now, you have 3 rules when it comes to horizontal asymptotes. Okay? And I'm going to refer to their degrees. So let's take a look at x squared minus x minus 1. What is the degree of that polynomial? X squared minus x minus 1. What is the degree of that polynomial? 2. Its highest power is 2. Look at the bottom one. 2x squared minus 4x minus 16. What is its power? 2. Okay. So when I talk about the degree or the power, I'm talking about the leading term. Okay? I'm talking about the leading term. The degree of the leading term. Okay? All right. 3 cases. If the degree of the P of X, is greater than the degree of the Q, there will be no asymptote. No horizontal asymptote. I'll just say none. No asymptote. None. So if I had an x to the 4th over an x squared, right? A 4 is higher than a 2, so we wouldn't have a horizontal asymptote. Let's go to the next. If P is less than Q, the asymptote will be at y equals 0.
Okay.
If the degree of P is less than the degree of Q, then it'd just be at the y equals 0. So what's left? We've had greater than, less than. If they're equal, if P equals Q, then it's going to be the ratio of their coefficients. It's going to be the ratio of their coefficients. Okay. In this case, we have what? Case 1, 2, or 3? 3. They are equal. Look up here. We have x squared over x squared. Right? So we're going to go with our third option. What is the coefficient of x squared? What's that coefficient? 1. So we're going to have 1 over, what's the coefficient of the 2x squared? 2. All right? That's it. That's your horizontal asymptote. Since it is the horizontal asymptote, that will be read as y equals. I'm going to do it backwards since we can. So your horizontal asymptote is y equals 0. Okay? All right, so what did we do? We found where the hole was. We found where the zeros were. And when I say zeros, you guys, what am I saying? Where does it cross the x-axis? Where does it cross the y-axis? Right? The intercepts.
Okay, what is P equals something over here? P equals Q. Does this say ratio?
The ratio.
The
The ratio of the coefficients.
Okay. Okay.
Oh, already.
So in one problem, we were able to find the asymptotes, we were able to find the x and y intercepts, and the holes. Okay? Stop.
Somebody's a warrior now?
Oh, I just searched up some algebra jokes. I was about to spit those out. Trying to find